Hello everyone, we've solved by graphing, we've solved systems by substitution, now we're going to solve by elimination. Now before we do this, I'm going to kind of do a problem sort of the long way using substitution, and hopefully we start to see why maybe elimination can sometimes be a better strategy. So if this says first solve the system by substitution, when you do substitution, you need to have a variable isolated. That means either x equals or y equals. We don't have that just yet, but you can see that there's a 1x. So what I'm going to do is take that equation, and I'm going to isolate the x by moving the y's to the other side. So x equals 12 minus 2y. Those aren't like terms, but now I have a substitution for x. In my other equation now, I'm not going to write x. I'm going to say 3 times, and I'll say minus 2y equals negative 4. So this equation is not changing, except for x. I'm not going to write x. I have a substitution for x. It's 12 minus 2y. The reason we're doing this is because now we have an equation with one variable. So if you have one variable, you can solve for y. To do that, I'm going to distribute. 3 times 12 is 36. 3 times 2 is 6y. And then we still have minus 2y equals negative 4. 36 minus, those are like terms. Negative 6 and negative 2 make negative 8. Now we have a two-step equation. We're going to leave y on this side. We'll move the 36 to the other side. Negative 8y equals negative 40. Negative 4 and negative 36 make negative 40. And last, we'll divide by negative 8. So y equals a negative divided by a negative is a positive 5. Once you have y, you can go back and get x really anywhere you want. I'm just going to use this formula because it's easy. 2 times 5. So x equals 12 minus 2 times 5 is 10. X equals 2. As an ordered pair, that's 2, 5. That is the solution to our system. It says graph it, but I'm going to actually do the same problem with elimination. We'll see if we get the same answer. So 2, 5 is our solution using substitution. Now, you might have thought, that was a pretty tedious problem. And you're right. In this example, it's already set up to solve using what we call elimination. The elimination method, instead of creating one equation with one variable, by substituting, where we throw an x or replacement for x, we substitute, we're going to actually combine two equations into a new equation. And when we create this new equation, the goal is to have still gotten rid of one of the variables. And you'll see this one's very easy because it's set up. If you add these equations together, you have 1x plus 3x, that makes 4x. 2y and negative 2y, that makes 0. So those cancel out, and 12 minus 4 is 8. You have a one-step equation where when you divide, you get x equals 2 almost immediately, which is nice. Now, once you know x, you can go back, and it doesn't matter which of the two equations you pick. I'm going to plug it into the top one because it looks easier, but it'll work in both. If I plug 2 for x, and now I solve this equation, 2y equals 10, so y equals 5, and I end up much faster. X is 2, y is 5. Notice, same answer, but a much faster way to get there. Okay, so this is called elimination, and again, when you added these two equations together, we got one equation with one unknown, and that's something we can solve. If it's set up, elimination can oftentimes be very fast compared to substitution. So which is more efficient? Well, I'm going to say in this example, and I'm going to type, is elimination. Elimination is more efficient because y cancels out in one step. That's great. Anytime one of the variables cancels out in one step, that's going to be really easy to do. So if I wanted to create one where that happens, I could just say like x plus y equals 5, and then I'll say like 3x minus y equals 6. This would be nice because those would cancel out. And now, I'm not going to actually solve this, but what I want you to think about is when these are opposites, it's set up and you are going to be done very quickly. So that would be one that would be easy to solve using elimination. Let's do some practice problems. I think I've got 3 or 4 of them, and we'll see how we do. Maybe it's 5. Okay. So first thing, you can tell in this problem that it is set up for elimination because you have 5x and negative 5x. Those cancel out. And when you add 4 to 3, you get 7y, and 30 plus 5 is 35. Now we can divide by 7, and in almost one step, we have y equals 5. Again, it doesn't matter which equation you pick. I'll just pick the top one, 5x plus 4. Instead of y, I know what y is now. Y is 5. So I'm using this equation, but instead of y, I'm plugging in what I just found, this 5 right there. Now it's a one variable equation. I can solve that. 5x plus 20 equals 30. And now it's a two-step equation. Minus 20, 5x equals 10. When you divide both sides by 5, you get x equals 2. And I would encourage you to write your answers as an ordered pair. So again, 2, 5. Is that the same answer? 2, 5? Okay, we keep getting 2, 5. Fine. One thing you can do to check it, if you use the top equation, you can plug it into the bottom equation, negative 5 times 2 plus 3 times 5. Does that equal 5? I'm plugging it in here. Is that a true statement? Is negative 10 plus 15 equal to 5? Yep, so I know I did it right. Okay, if you plug that ordered pair into both of these equations, it will make a true statement. And that's how you know you did it right. Let's try another one. All right, this one is not set up, so we're going to have to mess around with this one. Because right now, you add them together, you get negative 15 and negative 21. Neither of them went away. Bummer. So, we'll look at it and say, this is negative 10. I really wish this was positive 10, because then it would cancel out. So how can we get that to happen? Well, I could multiply negative 5 times negative 2. But the trick is, if you multiply this guy by negative 2, you have to multiply everything by negative 2. So I'm going to redo that underneath here. Negative 2 times negative 5 is 10. Negative 2 times positive 7 is 14. This seems weird. And negative 2 times negative 7 is positive 14. So, wait a minute. X is canceled, but y is also canceled. So when everything cancels, you get 0. And negative 30, I'm looking at these two, not this guy. So these two. Negative 30 and 14 make negative 16. 0 equals negative 16. No, it doesn't. No matter how hard 0 tries, it's never going to equal negative 16. Something must be going on here. And what's going on here is there is no solution to this problem. These are parallel lines. No solution. Okay? So if you see that you have one where you get a false statement like that, there's no solution to this. These are parallel lines. And if you really want to get convinced, solve them both for y. I'm going to do this quick. I'm going to add 5x and then divide by negative 7. So negative 5 over 7x plus 1. If you convert this one to slope-intercept, you get that. I'll do the same thing with the other one. Again, I'm going to do this pretty quick. Add 10x to both sides, 10x minus 30, and then divide by negative 14. And you get y equals 10 over 14. Those are both even. Cut them in half, and you get 5 over 7. And 30 over 14 is going to be 15 over 7. But notice, they have the same slope, and they have different y-intercepts. These are parallel lines. Okay? They have the same slope, negative 5 over 7. We've seen that when we did graphing, but we haven't seen it a lot with the elimination. So what happens is, when you get a false statement, like it was 0 equals negative 16, no it doesn't, no solution. They're parallel. All right, let's see. 2 goes into 4 and 3 goes into 9, so it doesn't really matter how you do this. I'm going to make that a negative 4, and the way I'm going to do that is multiply everything by negative 2. So I'll write that underneath. Now it's negative 2 times 2 is negative 4. Negative 2 times 9 is negative 18. And negative 2 times 12 is negative 24. Now notice, when you add these two equations, and I'm looking at, I'm making a mess here. Those two are what I'm looking at. 4 and negative 4 make 0. Nice. 3 and negative 18 make negative 15. And negative 6 and negative 24 make negative 30. So we have one equation with one variable. Divide both sides by negative 15. Y equals 2. Okay, y equals 2. Nice. Once you have y, you need to go back and get x. So 2x plus 9 instead of y, I'll put 2. I'm using the top equation. I'm just putting 2 right there. 2x plus 18 equals 12. So when you subtract 18, you get negative 6. So x must be negative 3. So as an ordered pair, negative 3, 2. Okay? What else we got? So let's see. We're going to, how do I want to do this? I got distracted. Let's, I could make this positive 8. That'll do it. Let's multiply it by negative 2 again. Okay, negative 2. So I'll copy the first equation. And if I multiply it by negative 2, I get 8x minus 2y. This might be another weird one. Oh, no. This is going to be a weird one. Okay, what's going on here? By. When you add them together, negative 8 and 8 make 0. 2 and negative 2 make 0, so on the left side you have 0, and 26 and negative 2, you get 0. Now, we talked about this weird one where we got a false statement. 0 doesn't equal negative 16. But here, 0 does equal 0. That is a true statement. So what's going on here? I'll tell you what, I'm going to convert them to slope-intercept, and we'll see if we can figure out what's going on. So if I take this top equation and add 8x to both sides, I have 2y equals 8x plus 26. And when you divide everything by 2, you get y equals 4x plus 13. If you look at this equation, if you add 4x to both sides, y equals 4x. Oh, I see. So here we have a true statement. 0 does equal 0, and it will always equal 0. And what's happening here is there are infinitely many solutions. And that's because these are the same line. They're just in slightly different, they're in multiples of each other. So there's infinitely many solutions because this is the same line. Okay, so if you say how many times do they intersect, well, every point that's in one is in the other because they're the same line. So we say there are infinitely many solutions. All right, last one. Let's see what happens here. 5 goes into 15 3 times. I want this to be a positive 15 though, so I'm going to multiply by negative 3. And if you multiply one term by negative 3, you have to multiply all of them. So I'll distribute. Negative 3 times negative 5 is positive 15. Negative 3 times negative 3 is positive 9y. And negative 3 times 3 is negative 9. So when I add these two equations together, that goes away. 9 and 2 make 11y, and negative 2 and negative 9 make negative 11. So when you divide, you get y equals negative 1. Once you have y, come up here. Doesn't matter which one we pick. I'll just pick the top one. Oops, negative 5x minus 3 times negative 1. Okay, so I'm using this original equation where y equals negative 1. So negative 5x minus 3 times negative 1. Negative 5x plus 3 equals 3, because negative times a negative is positive. I'm going to get 0. Okay, negative 5x equals 0. So when you divide, now, this 0 divided by negative 5 is 0. That's a number. X didn't go away. You still have 1x. So it's not like the other one where everything canceled. Okay, you just divide it. So you have 1x equals 0. 0 is a number. It's fine. So the intersection is 0, negative 1. That's our solution. And again, just because I feel like it's a good idea to check it, I'll plug it in the bottom one. Negative 15 times 0 plus 2 times y is negative 1 should equal negative 2. That goes away. Negative 2 equals, oh, yep, okay, good. I know I did it right because I got a true statement. So this is called elimination. You've already done substitution. You've already done graphing. Elimination is probably your most powerful strategy when we get to 3 variables. So make sure you're good at this and make sure you hit that like and subscribe.